For today's math lesson, I want you to go to the next free page and make sure the holes are on the right. If you have a page where the holes are on the left, then you're not going to write this. So one more time. If you turned to the next free page, so the last thing you did was predict and multiply. If you turn it over and the holes are on the right, you need to write this statement. If you turned your paper over, but the holes were on the left, like this, you turn the paper over and the holes were on the left, then you don't need to write this statement. We're just trying to get everybody to be on the front side of a paper. So again, if you turned it like me and the holes are on the right, then you need to write this. Moving on to dividing with fractions. And draw a big green arrow. So we're doing division now, not multiplication. I love dividing with fractions. It's really, really cool. It is definitely a little bit harder, but I think you will enjoy it. So after you write that, if you needed to, then turn your paper. Now the holes should be on the left. Those of you who didn't need to write that, you can just begin writing now. So go ahead and pause the video after you get out your green crayon to make your journal look like this. We are going to begin to understand dividing with fractions. This is part 1 of 3.10. So it's going to take us a couple days to really understand this. So get your thinking caps on and hold on tight. Here is what the little cloud says. It says, using division is finding new equal-sized pieces. So it's finding how many groups of something. How many equal-sized groups of something, okay? So what I want to write is near this cloud, I want to kind of come out with an arrow that goes down. I'm going to say, what does this mean? Well, we're going to answer that. This means a couple different things. This means, we're going to put a dash point here. This means equal size groups. Which we said pieces here. It means that it's fair. You ever played a card game before and you deal cards? That's called a fair share. It's the same amount for everyone. No one gets any more than someone else. It's the same amount for everyone. We're going to just call this a fair share, or we'll say sharing is caring. And you can put a smiley face by that. When we share something evenly, we are dividing it into equal size pieces or into equal size groups. So we have a couple different things of what that could mean. These are just some basic understandings. But something else that I really want you to understand is when you divide with fractions, you need to know your fact families. Okay? So when dividing with fractions, I'm going to write that right here. You need to know your fact families. If you remember back to what we've learned before, fact families are used with multiplication and division. You can actually use them with addition and subtraction as well. But what we do for a fact family is we draw it like a triangle. We're going to do a couple different fact families here, maybe 3. So here's what I mean by you need to know your fact families. If I have, let's say I say that the problem is there's a 6 here, and I say that the problem is 6 divided by 3 equals what? So the other number would be 3, and this time, because it's division, I'm not doing 6 times 3 is 18. I'm doing the other number that would build up to 6. So 6 divided by 3 is 2, right? So we'll circle that 2, and we'll put it right there. 6 divided by 3 is 2. You could also say it this way. 6 divided by 2 is 3. You could work that backwards as well. So these are called quotients. The answer to a division problem is called a quotient. Remember that if we do multiplication, then we're finding a product. But these are called quotients. Another one, let's see if we can do this. Let's put these in a fact family. Let's put 20 and 5. And you try to find that missing member. Find the quotient. So 20 divided by 5. And then I want you to solve that on your own. And then let's come over here and try this one. Let's do 18 and 9. And you're trying to find that missing fact member. Remember, we're using division. Go ahead and solve both of those. If on the first triangle you got 4, your answer was correct, because 20 divided into 5 groups is 4. If your answer to this problem was 2, then you are correct as well. 18 divided by 9 is 2. Will you write the reverse of that as well? 18 divided by 2 is 9. And this reverse is 20 divided by 4 is 5. So this number right up here that we put at the top of our fact family is our dividend. The number that we put over here either on the right or left are the divisors. And then whichever one we didn't use becomes our quotient. So we have dividends at the top, divisors at the bottom, or quotients, depending on which one you use. Okay, so to make something fair, I'm going to come right up here to the it's fair. We have to share. Okay, think about dealing out cards. Fair share means everybody gets the same amount of cards, right? So let me give you an example of a situation when that would be a little more difficult. And because we've just dealt with whole numbers, let me give you an example of when dividing with fractions would become a little more difficult. Let's say we'll do a problem like this. 6 divided by 1/2. 6 divided by 1/2. Okay, so you have to think about this for a minute. It means you have 6 of something. I have 6. So I'm just going to point a little arrow up to the 6 and write what I have. I have 6. So let's go ahead and draw 6 circles. 1, 2, 3, 4, 5, 6. I have 6 circles. And now I'm going to divide them into this size piece. So when I divide something with a fraction, with this is the size of piece. We'll say size of pieces. So I want to take all 6 of these and I want to make them be halves. Does that make sense to everybody? Okay, so I take all 6 of these and I go, I'm going to cut you in half, and you in half, and you, and you, and you, and you. So I just cut all 6 of those pieces in half, right? The answer to this problem is 12. And I want you to stop for a minute and think about that. How did I start with 6 and break them into pieces and end up with 12? Well, here's why. It's not that I have 12 holes. I have 12 pieces. Let's just double check that. I have 1 half-size piece, 2 half-size pieces, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 half-size pieces. So I don't have 12 holes. I have 12 1/2 sized pieces. So when I'm looking for the answer to a division problem, I'm not necessarily looking for how many holes. I'm saying how many equal sized groups of this, of a half, can I get when I started with 6? So if I have 6, how many equal-sized groups of a half can I get? I can get 12 half-sized pieces or half-sized groups. Does that make sense? It is a little complicated, so let's do another one over here. Let's say I started with 5, and I'm going to divide it by a third. So when we deal with something that's not even, it's easier to do rectangles. So let's draw. Remember, this 5 is what I have. So I begin with 5 rectangles. 1, 2, 3. I'm running out of space. That's only 4. So I'm going to draw another one over here. 5. Try to get them as equal as possible. So this is what I have, and I'm going to break them up into this size piece. This size piece. I have 5 holes. I want them to be a third of the size, right? I want to see how many 1/3 groups can I get out of 5. So I break up all of these into thirds. Here we go. Actually, I should use green. We'll go like this. We got to break up all of them into thirds. So how many, remember this is 1/3. How many 1/3 size pieces did we get out of this? You ready? Oh yeah, we're numbering. This is 1/3. This is 2 of the 1/3 size pieces. This is 3. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It doesn't mean I have 15 holes. It means I have 15 groups of a third in 5. So this is 15 groups, or pieces, whatever you want to say, groups of 1/3. So you have to look at the answer, the quotient, you have to look at that differently than you did with multiplication. I'm not looking at the total holes. I'm looking at, how many equal-sized groups could I get out of that? How can I make it fair? If I have 5 and I want to cut all the 5s, the whole 5, into thirds, how many of those third-size pieces would I have? Once I understood that, I understood a lot more of what was happening with dividing with fractions. So if you are struggling with, modeling this out, then we can work on that together. But this is going to be really important that you understand something like this, okay? Another situation that might happen, this is really interesting, is these are taking wholes divided by pieces. A whole divided by a fraction, right? Whole divided by a fraction. So maybe we ought to make that a little bit of like a title up here. These were whole numbers divided by fractions. That's what we just did for both of those. We did some whole numbers divided by fractions right here. The next thing I want to do is do the reverse of that. So let's do a fraction. So starting with a fraction divided by a whole number. So let's write that title. Now we're going to begin with a fraction divided by whole numbers. This one seems confusing, but it actually makes a lot of sense if you think about it. Let me go ahead and just give an example. So let's just write that the problem is 1/2, because there's a fraction, 1/2, and now I have to divide it by a whole number. We'll divide it by 3. So remember, the first number is always what you have. This is what I have. The second number is how many people I'm sharing it with, or how many want an equal size piece of whatever that was. So this is what I have, and this is how I'm breaking it up. So how do I show that I have half of something? Let's say a candy bar. I have half of a candy bar. Well, you can't show half if you don't begin with a hole. Let me explain what I mean by that. There's a whole candy bar, right? Do I have a hole to begin with? No, I only have half. So I cut it in half, like this, and I'm going to show, by like coloring or something, that this is what I have. I have half a candy bar. So not along with me, I have half a candy bar. Now I have to take that half and I have to split it into 3, because this is like saying I have half a candy bar and I'm going to have a piece of it and I'm going to give a piece of it to 2 more friends. So me and 2 more friends make 3. So I have to split this half. I have to give it to 3 people. So to split this into 3, you have to have 3 equal size pieces. So notice I'm covering up the hole because I only have the half. And I need 3 pieces out of there. So I just go like this. Okay. I need 3 pieces. So I go whoop and whoop. You're going to make them as equal size as possible. I always like to make my lines come out of the box a little bit, just so I can show that I'm cutting that. Okay. So this is friend number 1, this is friend number 2, and this is friend number 3. They would all get a piece of that half. They're going to get an equal piece of that half. I'm not going to give one friend more or keep more for myself. I'm going to make it equal. Okay? Well, then the answer, each friend would get how many? 1. They're going to get 1 of those pieces. So each friend would get 1 of those pieces. But the answer is, what size piece are they? Are they thirds? No, because they're thirds of a half. So they're not thirds, so you have to unveil the whole in order to figure out what size piece of the candy bar is this right here. Remember, this is 3 pieces, but it's only half. So you'd have to go like this. Well, in order to know the size of piece, I have to split the rest of the whole up. I have to pretend that that whole candy bar was split into these equal size pieces. So even though I don't have that amount, I still have to split it into those pieces so that I know what size pieces they were. So there are 1, 2, 3, 4, 5, 6. There were 6 pieces in the whole. So that is my denominator. There were 6 pieces in the whole. So I'm going to write that. There were 6 pieces in the whole. So that is my new denominator. There were 6 pieces in the whole. So that's why 6 is my denominator. And how many pieces of those 6 did a friend of mine get? Each friend got 1/6. So here's how this works. It sounds crazy, but those of you who are pretty great with math, listen carefully. I can get 1/6. Listen to this. I can get 1/6 of a group of 3 if I only start with half. Pretty crazy how that works, huh? I think that's a little complicated to understand, so I like to think of it like this. I had half of a candy bar. I had to share it with 3 friends. So each one of my friends got 1/6 of a candy bar. They didn't get 1/3 of a candy bar. I didn't even have a whole to start with. But you have to break up the whole in order to know the denominator, in order to know the size pieces. Let's do another one like that. Okay. Let's do where we start with a fraction and we divide by a whole. Let's start with 1/3 this time. So we're going to have 1/3 of something. We'll say we have 1/3 of like, you want to do a candy bar again? Sure, we'll do a candy bar. And this time I want to split it with 4 people. So remember, 1/3 is what I have. So in order to show 1/3, you have to draw. We're going to do it vertical this time. There's my candy bar. I have a whole candy bar. Well, I don't need a whole. I only need a third of that candy bar. Okay, so I'm going to split this with my green into thirds. Okay, how many of those do I have? 1/3, 2/3, or 3/3? 1/3. I'm just going to start at the bottom. Color what you have. So I have 1/3, which means I completely ignore the other part. So I have a third. I need to take that third and evenly share or fair share it with 4 people. Okay, so I have to share that with 4 people. You have to keep your lines going the same direction that you cut it in the first place. So I went left to right, so your other lines have to go left to right as well. So I need to share it with 4 people. You ready? So it has to be like this. That's in half. And then this, and then this. Does that give me 4 pieces? 1, 2, 3, 4. Yep. This gives me 1, 2, 3, 4. So how many of this would my friend get? If I had 4 friends, they're each going to get 1 piece of that, remember? So that equals, they're going to get 1 piece of that. But what's the denominator? It can't be 4 because they didn't get a fourth of a candy bar. That wouldn't make sense. If I gave them each a fourth and I had 4 friends, so I gave this one a fourth, this one a fourth, this one a fourth, and this one a fourth, that would be 4/4, which is a whole. I didn't start with a whole candy bar. I only started with a third. So it can't be fourths. This is why you have to break up the whole. You have to continue to go, okay, so I'll cut that one into fourths, and I'll cut this one into fourths. And now you'll know, sorry, that line's a little crazy. You'll know your new denominator, because this is 4, 5, 6, 7, 8, 9, 10, 11, 12. There were 12 pieces, and I only gave my friend 1 of those 12 pieces from the candy bar. Kind of crazy to think about, right? So it's really interesting. If you start with a fraction and you divide it by a whole, you're going to get a smaller fraction. Think about it. You can't get a bigger fraction if you start with a little bit and then split it. You're going to get a really tiny fraction. Same thing over here. If I start with a fraction and I split it with people, I'm going to get a smaller piece than what I started with. That makes sense. Come back up here and see if you can remember this. If I begin with wholes, like I have 6 of something, 6 whole things, and I cut them into pieces, I'm going to end up with more pieces, not less pieces than 6. I'm taking 6 wholes and cutting them into pieces, so I get a lot of pieces. Same with here. I started with 5 candy bars, and I cut them into pieces. So I didn't share it with friends, I just cut it into pieces or into serving sizes. And it ended up with 15. So they are very different depending on which number you are given first. So make sure you always write it correctly. If you're given the whole first, then you would draw wholes. If you're given a piece first, you draw the imaginary whole and color what you actually had. Then you split the whole thing into pieces. Pretty crazy, right? We'll see you in the next video to find out what we do next.